Well, or that was the Foxhole one.
That was the Foxhole one.
All right, good evening, everybody out there. I'm Tom, W5KUB, and this is Amateur Radio Roundtable. We're on every Tuesday night at 8 o'clock. I forgot the time. We also, our show is also broadcast on world famous WBCQ, International Shortwave. And let me just make a quick announcement for you people out there that might be listening on WBCQ. We just moved to WBCQ's 7490 transmitter. So we got a new time slot. This show can be heard on Thursdays from 5 o'clock to 7 o'clock p.m. on 7490 kilohertz on WBCQ. And back in the olden days, that would have been kilohertz, hertz cycles. It would have been kilocycles back in the olden days, man, but we're not back here. So listen, hey, if you're out there listening on shortwave, we want to invite you to join our Facebook group. It's called W5KUB, and we've got over 11,000 hams in that group now. We'd love to have you join our group. And you can watch the show live. We're live every Tuesday night, 8 p.m. Central Time on W5KUB. All of our shows are recorded. You can watch them at any time. So just want to let you know about that. Just a couple other announcements real quick. Hey, I talked to Anthony tonight on the net, 40 meter net. The band was terrible tonight, but we had 3 or 4 stations to get through. So Anthony down in Texas, he and his wife are still getting over COVID. The COVID-19, I think he's doing okay. He sounded okay. Also, I haven't heard from Ken. Ken. He's another one of our members. He and his wife had COVID. And I just saw in a chat room that Bruce, N7XGR, has the COVID right now. And I did not know that. Bruce usually checks the internet every week, and I did not know that. So, guys, take care of yourself there, and hopefully you'll kick that thing real soon there. Our net tonight, we went to a different frequency tonight. I think we were on 7189, or somewhere like that. I saw a note where the RRL sent out a message saying that the Caribbean hurricane net, they were trying to pass traffic in the Caribbean, and they were using 7180. That's the frequency that we would normally use for our net. I did tune in at 7180, and there were a couple of real strong guys just chatting on there. I guess they hadn't got the message. So anyway, we did move off of there. Got a good show tonight. Alan's going to talk about some different signals and I think the modulation envelope and how they look like and so forth. And we've got Bill on here. Bill, he is our master of high altitude balloons. And Bill's going to tell us and give us an update on W5KUB-20, where it is and where it got stuck and where it's going to go. We got Glenn on here. He's got something to go. So not sure what all else we're going to talk about tonight. Don't know how much time that's going to take, but we're going to have fun doing it, and we'll see where it goes. So let's pick up Alan real quick. And Alan, first let's go around the room here. Alan, how you doing?
Hey, we're hanging in there. Work's been pretty busy, and been pretty busy with stuff outside of work as well. But I just playing around after our session last week on the 260. And since I had all my 260s up here, I took a picture of the face of one of them to use as my background here. Afterthought here, I should have done that before the show last week. It would have been a much more apropos thing. But anyway.
Well, that background looks amazing.
A week after time, I've got backgrounds that are a week late. So what can you do? So anyway, tonight on Tech Tips, I thought we'd chat a little bit about spectral content of different types of modulated signals, like CW signals, AM, upper sideband, lower sideband, FM.
Okay. Hey, before you get into it, let's pass it around and say hi to Glenn and Bill there, and then we'll come back and we'll jump right into your presentation.
Oh yeah, no, I was just introducing.
Oh, okay,
it. Yep,
okay.
No problem. Yep, no problem. Okay.
Very good, dear. Very good. Okay. Glenn, come on in here, Glenn. How you doing, Glenn?
Oh, hanging in there, man. I'm probably about 2 weeks away from finishing the book. Just cranking stuff out daily. I have a couple pictures of one or two of the projects in the book. And like I say, it's getting real close to finally being done. I mean, that's about 3.5 years worth of research and putting together. So it feels good to be that close.
That's good. I know you'll be glad to get through with that book so you can start the next one.
No.
Yeah. Oh, man. All right. We'll see what else you got to talk to us tonight about. I know it's going to be interesting. Bill Brown. Hey, Bill, how you doing?
I'm doing okay.
Well, very good. You've been working. You know, you don't seem to be as active on Facebook or whatever as you used to be. You must be working more.
Oh yeah, it's been pretty busy. We're doing a lot Zoom conferences online, and been doing some school events where I talk about space science and ham radio to kids around the world. I just did one to a school in Melbourne, Australia, and it was kind of neat because I was actually talking to the future. It was 7 o'clock in the evening my time, and it was 11 o'clock in the morning in Melbourne, Australia the next day. But they had great questions, and they actually launched a balloon. I talked them through the process of launching a balloon, and it went out off the coast of Australia and went the second day it went past Tasmania, and last I heard it was on its way towards Antarctica.
All right. I hope you get all the detail about Dash 20. I want to know what's going on.
Yeah.
We'll talk about that in a little while there. All right.
Okay.
Let's jump back over to Alan. Alan, let's talk about signals and how they look going through the air, I guess.
Yeah, I thought it would be an interesting topic because, people are always wondering, am I too close to the band edge? What about if I'm on upper sideband or lower sideband, or I need to tune up my antenna? Where should I be tuning, where I'm not interfering with the folks that are chatting and that type of thing. So I thought getting a better understanding of spectral content of signals might be helpful. So with that, let me up here, and let's see. Let's go and share a little bit of content here about this guy. So spectral content of amateur radio signals. Not going to be a long PowerPoint. I've got like 3 slides here just to kind of illustrate the point here a little bit. And so in most cases, we're going to talk about the spectral content of phone signals, but we'll actually talk about CW and some other things as well. So the first thing to think about generally is that what's the spectrum of your audio signal itself? Of course, it's going to vary with everybody's voice. It's going to vary with what you're saying. It's going to vary with the fidelity of which is being transmitted. I mean, the human voice can occupy frequencies below 50 hertz all the way up to and above, close to, even 10 kilohertz or more if you start thinking about the S's and little tips and tings that are in your voice. But for most communication quality audio, phone quality audio is typically about 2.4 kilohertz wide. 100 hertz to 2500 hertz is about the frequency range that most phone transmitters will do. Some will go up to about 3000 or 3500 hertz for kind of the hi-fi CW or single sideband guys, or even a little bit wider. But most phone quality audio is, the meat of it, if you will, is in this 100 hertz to 2500 hertz bandwidth. So that, the bandwidth of the audio signal, how much spectral content the audio signal occupies, has a direct impact on the spectral content of a modulated RF signal. So the first one, and the easiest one to think about up front, is amplitude modulation, or AM. When you take a simple carrier, without any modulation at all, you just have energy essentially at the carrier frequency and nothing on either side. Amplitude modulation creates essentially equal but inverted sidebands on either side of the carrier. And the carrier is actually still there. For a perfectly linearly modulated, even 100% modulated carrier, amplitude modulated signal, half the power is actually in the carrier, and the other half of the power is split between the upper and lower sidebands. So by its very nature, AM is somewhat inefficient because there's duplicate information, in the upper and lower sideband. They have the same information that's just spectrally inverted on the lower sideband. It's kind of flipped around like a mirror, but the same information is there. So you're sending the same information in two places instead of one. So it's inefficient from that standpoint. It occupies, therefore, twice the bandwidth that it needs to in order to transmit that information, because you really only need one sideband, not the other, in order to get the information through. And the impact of that is, less people can be on the bands because the signal occupies more bandwidth. And, having a receiver that has twice the bandwidth to receive it means you're also going to receive twice the amount of noise. So the signal to noise ratio is going to be worse because of the wider bandwidth, and therefore it's harder to hear weak signals. And then third, again, half the power that you're sending to your transmitter or sending out to the antenna is in a carrier which is containing no information content. It's just energy in that carrier. So this is why, as we move down the road, that people are looking at using upper or lower sideband, because you take the energy away from the carrier, you take the energy away from the lower sideband, or one of the sidebands, and you can concentrate all that energy into one sideband and use less bandwidth, so you get more efficient that way. But I thought it'd be helpful to actually look at this too, as well as what we're looking at here. So we're going to do that here in a moment. I'll actually fire up a rig and send it into a spectrum analyzer and actually look at it live. We'll do that here in a moment. But this is what AM looks like. I mean, you've got upper and lower sidebands that are equal but mirrored around the carrier, when you do amplitude modulated signals. So you have to think about, if you're operating AM, you want to ensure that your signal doesn't go outside of a band edge. You have to kind of consider the width of your audio signal, and therefore the width of the transmit filter in your rig. Are you going to go 2500, 3 kilohertz, wide on either side of the carrier? So you don't want to get in within, say 3 kilohertz of the band edge, upper or lower, and with your AM signal because of that. Now again, because amplitude modulation is inefficient for those number of reasons, this is why we started to do upper and lower sideband. So single sideband modulation essentially, removes the carrier, suppresses it, filters it away. Depending on the mechanism, it could be a filter process, it could be a phasing method. There's a number of ways of actually doing that. You get rid of the carrier, and then also getting rid of one of the sidebands. So at the end of the day, what you're doing is you're transmitting just the upper sideband, which is the upper sideband that would be part of the AM signal, or just the lower sideband that would be from the AM signal, but removing the carrier and removing the unused sideband. So the frequency that you occupy, let's say for upper sideband, is going to be everything above, your audio signal essentially above the suppressed carrier frequency. So if you had dialed your radio into say 14.200 megahertz, okay, that's where the suppressed carrier would be. But your upper sideband signal occupies, a couple of 50 or 100 hertz above 14.200, all the way up to close to 2.5 or 3 kilohertz above 14.200. But the ideal thing is that you don't actually have any energy at 14.200. So if you were going to go down to the lower edge of the band, you could go right down to your suppressed carrier frequency, provided you know that your lower sideband is being suppressed sufficiently, and still be in band. But if you're going to the upper side of the band, you have to recognize the fact that your signal is occupying as much as 2.5 or 3 kilohertz above your displayed frequency, which is the suppressed carrier frequency. So if you're going to go up to 14.350, you got to go 14.350 minus about 3 kilohertz to ensure that the high end of your upper sideband doesn't exceed that band edge. So this also has some implications. Let's say you got to hear a bunch of friends on say 14.220, but you got to tune up your antenna. Where do you go to tune up? Well, you say if you go slightly off frequency, you could tune up in an area where they won't hear you. And if in the case of upper sideband, you want to tune just a little bit below your suppressed carrier frequency, and you don't even have to go that far, right? Because once you're outside the suppressed carrier frequency, if you went instead of 14.220, you went down to the 119.5, you're 500 hertz below the suppressed carrier frequency. It's not going to be in the upper sideband. So when you tune up with your single carrier, like on CW really quick, you won't be heard. Where if you went 500 hertz the other way, you're going to be right inside that upper sideband. So tuning just below the suppressed carrier when you're doing upper sideband, you can tune up very close to the desired frequency without interfering with the folks that are already talking there. Similarly, for lower sideband, it works the other way. We still suppress the carrier, but now all of the energy in the lower sideband exists below your displayed suppressed carrier frequency. So if you're sitting at 7.180 to talk on the net, talking on lower sideband, if your radio is working properly, you don't actually transmit any energy at 7.180. All your energy is essentially the width of your voice, your audio signal, 2.5 to 3 kilohertz, spread around from just below 7180 down below that. So again, if you were wanting to get up on the net on 7180, if you tune just a few, 100 to 300 kilohertz on the high side of 7180, you won't be heard by everybody that's in the net. But if you tune off frequency down below, you will, you'll put a heterodyne in there and everybody will hear that. So, and then similarly, if you're working your way down towards the lower band edge, you've got to ensure that you keep your displayed, suppressed carrier frequency at least 3 kilohertz away from that lower band edge, because that's where your signal, your lower sideband signal will go. So I thought it'd be helpful to take a look at these live, again on a radio here. But let me just stop sharing here for a moment, and just maybe we'll just double check the chat to see if there's any questions there or not. And it doesn't look like we have any. So let's actually go and share a spectrum analyzer display here. It looks like everybody should be able to see that here now. So I've actually got my little FT817 rig here that actually I've figured out needs a little bit of an alignment, but that's okay. We can get through this here. So to start off with, I've got this thing sitting up at the upper end of the 10 meter band. It's like 29.6 here. And if I just key up in CW, okay, we can actually see my carrier at 29,600. I can see the phase noise. This is actually just phase noise from my CW transmitter of the radio itself, so nothing to be too concerned about. But that's what that's essentially my carrier frequency there. Now you'll notice if I start keying and actually sending CW, instead of just getting a narrow little tone here, we'll see that You can see that as I send, there's a little bit more width in that spectrum. In fact, let me go turn a max hold trace on here to go take a look at that. Okay. We can actually see when we're modulating, even CW, which is just turning a carrier on and off, you do occupy a little bit more bandwidth than just the pure CW tone by itself. It's just that act of turning it on and off is kind of the extreme case of amplitude modulation, right? Just turning the carrier on and off. So even though CW is a narrow band or a narrow mode, it's not zero, right? It does occupy some bandwidth, and typically a few hundred hertz or less. The faster you key, the faster your tone, the more bandwidth you actually occupy. So let's take a look at some of the other modes here. Let me go switch my rig here to AM. Let's see here. And let's go back to that same frequency. And there's enough noise pickup in the radio, in the audio circuit, that if I just key the microphone, we can see the carrier, and you can kind of see as I'm talking here, even though the microphone is sitting about a foot away from where I'm talking, you can kind of see that the sidebands on either side of that carrier are kind of equal and opposite, right? I've got energy in the carrier, and I've got energy coming into the sidebands. Probably a better way to see this is I'm going to turn on a little audio generator here and get my phone turned on here. And let's turn that on. And I've got a simple little audio tone being generated here. If I turn it up, you'll be able to hear it. Okay. And that simple audio tone you can see is creating a sideband just above and just below. It's about a 1 kilohertz tone. So I've got a upper and lower sideband that's 1 kilohertz up and 1 kilohertz down from the carrier. If we change the frequency, let's see if I can do that here. As I change the frequency, we can see how that sideband moves out, and everything remains symmetrical. Okay, and that's very typical of AM. Let me turn that off here. So AM creates that the carrier and the modulation sidebands. And even as we change that modulation depth, let's go back and do that. Okay. As I change the amplitude of that signal going into the radio, you can see the carrier magnitude doesn't change. Even if I'm bringing the mic up closer and further away from the audio source, we can see the carrier power remains the same. Even when I get to the point where I get close to essentially 100% modulation, we're never going to, the carrier power is always going to be there. And again, that carrier is not carrying any energy. Right, the carrier is just there to essentially complete the RF envelope of that RF signal. So it's kind of wasteful in terms of power. Let's take a look at what happens when we look at upper or lower sideband. So let's switch this over to, let's see, let's go to upper sideband here first, and I'll just key the mic away from any other source. And you can actually see there's just some noise in the audio circuit. And you can actually see, remember my carrier is right here in the center, right? And but now I can see all of the energy is concentrated just on the one side. My lower sideband essentially isn't there, it's being suppressed. And we can especially see that just by looking at that noise that's there. So that's what upper sideband looks like. We remove the carrier, we remove the lower sideband, and all the energy is now in the upper sideband. So this is where my dial frequency is, right here at 29.6. But again, I've got energy extending out to 3 or 4 kilohertz, 3 kilohertz or so above that. Let's switch it over to lower sideband here and key the mic. And now we can actually see that all the energy is down on that lower sideband. Okay, the carrier is suppressed, nothing in the upper sideband here, and all the energy is down here now in the lower sideband. And this becomes especially apparent when we start looking at that audio tone. Let me go bring that up. So there's that audio tone. When I'm not talking, you can see just that audio tone. Now you might say, you might recognize the fact that that's just a CW tone that's offset from my displayed suppressed carrier frequency by the audio tone frequency. But in some sense, it's no different than a CW signal. One way of generating a CW signal is just to create an audio tone that goes into a single sideband transmitter. Okay, and that's that's another way, and it's indistinguishable from a CW signal. In fact, most of the let me turn this off here. It's beeping in my ear. Most of the digital modes whether it's PSK31 or anything like that use the sound card to create tones and things like that, are literally just doing just that. They're creating tones, and even though the transmitter is in single sideband mode, or even if you're in some of these digital modes, it's actually in a single sideband transmission mode, and is just creating those tones in the upper or lower sideband. And the receiver at the other end doesn't really care where it came from. It doesn't matter what that tone offset is. It's just going to decode that signal like a PSK signal. Just look at the phase shift of that tone that's being created in audio, but then modulated on either the upper or lower sideband. So it's one way to kind of think about how all that works together. So the other thing we didn't really talk about is FM. And FM, you might wonder, so why don't we use FM on the lower frequency bands, like on HF? And the reason is that FM occupies a lot more bandwidth than even AM does, because AM again occupies twice the bandwidth of your audio signal, right? We talked about that because you've got an upper and lower sideband. With FM, the sideband generation is not just it's related obviously to the audio signal that's modulating it, but you also get multiples of those sidebands. There's a whole function called a Bessel function that determines the strength of all these multiple sidebands. And let me show you what I mean by that. I switched the rig here to FM. Let me put that tone back on here again, if I get my phone to turn back on here. Now this is an FM signal. The same tone being sent in it. Okay, and you can see I've got the same spacing, that 1 kilohertz spacing, for the audio tone, but I've also got another set of sidebands at 2 kilohertz, 3 kilohertz, 4 kilohertz offset. Okay, and the strength of those tones is a function of a couple of things: the modulation depth and the deviation. So you can see that the FM signal occupies a lot more bandwidth because there's more sidebands that are being generated. So we typically will do that, only on the VHF and above bands, because we've got a little bit more bandwidth to play with there, more frequency space to play with. So occupying 5, 10, 15 kilohertz of bandwidth doesn't hurt us. Occupying 15 kilohertz of bandwidth at HF would be rather obtrusive. That's typically why we don't use FM on the lower frequency bands. And even if you looked at broadcast signals, right? Broadcast AM, is down below 1.6 megahertz, right? It's just AM, so the bandwidth of the signal is equal to twice the audio bandwidth. But you get up into FM, typically 88 to 108 megahertz, and the occupied bandwidth of an FM broadcast signal is several hundred kilohertz because of this multiple sideband generation that's needed in order to accurately get FM signals through. So anyway, I thought that was just an interesting look at spectral content of different signals, what they look like, and some of the considerations that you might want to take into account when operating these different bands, and how close you get to the band edges, where your signal is, where the people you're talking to are listening to, and where you can safely tune up without interfering with them. So anyway, that's all I had for tonight. Just something, a simple topic, but sometimes I think a visual is worth 1,000 words. So. All
right. Well, that was great, Alan, and I like looking at the scope there, your spectrum analyzer, and seeing those sidebands in there. All right. Well, very good. Let's move on real quick to Bill Brown, and let's see what Bill's got for us tonight. It should be an exciting adventure with Bill tonight. Bill, give us an update on Dash 20. What's going on?
Sure thing. I have a question for Alan in a few minutes, too.
Okay. If you want to go ahead and answer that, go right ahead.
Oh, Alan, I have a question for you. Why is 40 meters and 80 meters lower sideband and 20 and above upper sideband? Is that just what is the reasoning behind that?
Well, I think it's kind of tradition now, but I think in the early days it got down to the point where most of the rigs and gear that hams were using for upper and lower sideband came out of the military surplus and things like that, which used for one reason or another a very common 9 megahertz IF. Okay, so the first IF in the rig was 9 meg. So when you were doing a frequency conversion into that 9 meg IF, you would get spectral inversion when you were below 9 meg and not get spectral inversion when you were above 9 meg. So the spectral inversion would invert that sideband. Okay, so therefore using the lower sideband made more sense. When you're converting the other direction, you were not inverting the spectrum, and therefore you'd use upper sideband above 9 meg. So the 9 meg was really the limit line. So that's why, so 20 meters is above 9 meg, 40 meters is down below 9 megahertz. So I think that's where it kind of came from, and it's just it adopted as tradition. There's no technical reason why one is better than the other. It just came down to the equipment that was available to hams when they were experimenting with single sideband in the earlier days, and I think that's really where it came down to.
And you know that standard is still being used today, particularly like in aircraft when I'd fly on our jets. The aircraft radios, they don't have a lower and an upper sideband switch on them. They just had the
the only place where we really broke that was for the 60 meter band. 60 meters upper sideband, and because it's below 9 meg by rates, it should be lower, but it's upper.
Yeah. Hey, you had a question in the chat room. They liked your presentation. Can you use it for teaching licensing classes? They want to know if they can use it, I guess, for teaching classes.
Yeah, I mean, if you could certainly, if somebody wants a copy of the quick little presentation, I can certainly make that available. If we can put it somewhere to download, that's fine. But I'd be happy to do that. If it's useful in any classes that you're teaching, I'd be happy for you to take advantage of that. No problem.
All right, great.
Looks like Darrell had a question about the 260 too. Oh, that wasn't a question; it was more of a statement. Okay.
Yeah.
Read the resistance of your body with the 260. Yeah, you can do that.
Yeah, you can. Yeah. And if you put the two test leads on your tongue, you can also taste it.
Oh yeah.
All right.
What spectrum analyzer were you using today, Alan?
Well, actually, I'll give you. It actually wasn't a spectrum analyzer; it's an oscilloscope.
Okay.
The oscilloscope that I was using actually has a built-in digital down converter, so it essentially has got effectively a spectrum analyzer behind every channel. It down converts into baseband IQ like a software-defined radio does, and then computes the spectrum right from the IQ data right in the So it's pretty cool stuff. But benefits of working for Tektronix.
We've got another question from N8DPR. I think N8DPR may be new tonight with us. I don't know. N8DPR, okay. Are you new tonight? Glad to have you. He says, why is FT8 on 40 meters upper sideband?
Yeah, well, that's, like I said, for the same reason. Yeah. I think with FT8, the program that you use, the application you use on the PC, is using the sound card to create the frequency modulated signal that's used by FT8. And the software is designed to decode the signal, assuming the modulation is going in one direction or the other. Mm-hmm. So in this case, it's actually assuming that you're not inverting the spectrum, you're going in one direction. So they're impressing the audio signal on the upper sideband, so there's no spectral inversion of the audio signal. If it was transmitted on lower sideband, the spectrum would be inverted. The software could probably be written to accommodate for that, but I think for most of the digital modes, they just make the assumption that you're going to put the rig in upper sideband mode. And but at the end of the day, kind of like I showed you with the CW signal on when you looked at single sideband, you select upper sideband, you put the tone or tones in there for your digital signal. That's all that appears is just those tones. They're going to be offset from the suppressed carrier, the displayed carrier frequency. But it's just going to be essentially a frequency shifted version of the audio signal that the computer and sound card are making. And by putting it all on upper sideband, you don't get any spectral inversion on it. So that's probably why most digital modes, including FT8, will use the rig in upper sideband mode to create that narrowband modulated signal.
All right, cool. All right. If there's any more questions, put them in the chat room. We'll get them to Alan. Also, send Alan an email if you're interested in that presentation, and he can get it to you.
All right, cool.
All right, everybody, stand by. We'll be right back in about 2 minutes.
Okay.
This compact rig weighs in just over 2 pounds with RF direct sampling for most of the HF bands and IF sampling for frequencies above 25 megahertz. It also has a large 4.3-inch color touchscreen with live band scope and waterfall. You get 5 watts with the BP272 and 10 watts with a 13.8 volt DC power supply. It has a micro USB connector, Bluetooth, and WLAN. Integrated GPS with antenna and a GPS logger. It has a micro SD card slot. And the HM243 speaker microphone comes standard. The perfect accessory for the IC705 is the LC192 backpack. It has a special compartment for your IC705 and room for all your accessories. The IC705 now has received FCC certification, and we expect product to be shipping to dealers by the end of September. Visit www.icomamerica.com/amateur for more information on ICOM radios.
To QRO, fixed stations, portable and remote, an LDG tuner will match your radio to your antenna using our lightning-fast proprietary tuning algorithms. LDG is a family-owned and operated company dedicated to bringing innovative, quality products to the amateur market. All LDG products carry a full 2-year warranty that is fully transferable. Support is only a phone call or email away. We're always here to help you. Visit us on the web at ldgelectronics.com.
Okay, and we're back, and there's Bill. Bill's with us. And Bill, tell us what's going on with W5KUB-20, man. You know, we're going to try to break our record of 3 revolutions in 72 days. I don't know if we can do it or not, but we're going to try. What's going on with it?
Well, it was moving right along, and then it decided to take a little southerly track across India, right through the central part of India. And when it's in that part of the world, there's not a lot of whisper stations to listen for it, to get data back from it. Fortunately, I'm a member of the New Delhi Amateur Radio Club in India, and I alerted my friends there to start listening on whisper. And I think you had a guest on that did the microbit
that was Farhan
radio.
Sure, Farhan.
And was he listening for it as well?
No, I haven't contacted him yet.
Okay. Well, I got 3 or 4 whisper stations to pop up in India as a result of my Facebook plea, and they all of a sudden there's a whole bunch of whisper stations listening in India, and we got some really nice reports on your position as we came across India as a result. So it pays to have friends in remote places. So then it decided to go to Burma, which actually is called Myanmar now. Yeah. But it originally is called Burma. And I have a theory. It spent a whole day and a half going in circles over Burma. And I think you have some slides of what the sky ants were really looking for in Myanmar.
I think they were checking the signs out. Probably many people watching the show don't know what this is. They've never seen these. They don't know what these are. Let's even ask Alan. Alan's a pretty young guy. Alan, do you know what this is?
I gotta unmute my microphone there. Yeah, I've seen the signs.
Okay.
Like I said, I haven't really seen, but I have seen this on the highway. I remember seeing the signs sitting in the back of the station wagon as a kid.
Okay, there you go.
On the highway, but that's about it.
Well, there they are, 1925 to 1963. Boy, when you drive down the highway, you look forward to seeing the Burma shave signs. And I guess, Bill, I guess that's what they were doing, man.
One after another. Yeah. Here's one example.
Yeah. And they spaced these signs out like every mile. So you'd read it and you'd have to wait for a mile to get the next little bit and the next little bit, you know. And it's kind of
Kind of reminds me, I don't know if you've ever traveled south on I-95 through, from like down the East Coast through New Jersey, Maryland, Virginia, and North Carolina. There are signs that start several hundred miles from the North Carolina-South Carolina border for a little attraction called South of the Border.
Oh, yeah?
And
Yes.
like as
I've been there.
Pedro says, be sure to visit south of the border in 272 miles. It's like every 50 miles there was another sign. I think they've taken that from the Burma shape thing. So.
And when you go across South Dakota or North Dakota, I can't remember which, but there's Wall Drug is in the western part of the state, and as soon as you cross the border, every mile for about 400 miles, it says "See Wall Drug, see Wall Drug," and you have to pull off.
All right, so we've got off on Burma shape. But let's get back on track here.
The Sky Ants apparently saw a bunch of Burma shave signs over the country of Burma.
Yeah.
Checking it out. So, but fortunately, they got through Burma, Myanmar, and they are now cruising through China. They made it into China last night, and on the western part, and they're picking up speed. They're finally getting into the jet stream again, and because you were kind of out of it and going in a circle and a vortex.
So there we are. There. That was about 30 minutes ago. So we've traveled about another 25 miles, I guess, since it came on. But
yeah, it's daylight over China right now, and so the balloon started transmitting about an hour or two ago, and it's near Shanghai, and hopefully we'll go out east and hit the big jet stream and get across the Pacific Ocean in a day's time. We had a transmitter on the same balloon you're flying with one of my trackers on APRS. It was over Japan 2 days ago, and it just showed up in San Francisco today. Yeah. So if you hit the right winds across the Pacific, you can get across in a day or two.
I think you have a much better prediction, but here's what HabHub is showing, and I don't like what I'm seeing.
I just ran a manual prediction on.
Let's see what your prediction shows.
And mine shows it going. If I can share it here.
But this is not uncommon. We, all of our flights, we've made quite a number of circles. Okay.
So can you see that?
I see it. We're going to do a little figure eight.
Actual prediction I just ran.
We're going to do a figure eight.
It's leaving Shanghai and cruising down to the Philippines.
All right,
and it looks like it's going to spend 1, 2, 3, 4, 5, 6, 7 days.
Oh man!
Going in circles over the Philippine Islands.
7 days over the Philippines.
Right. And you're going almost down to the equator. You're going down below 10 degrees latitude. And some of my analysis shows there is maybe a 10 or 20% possibility you could actually catch the right winds and go into the southern hemisphere and start circling in the southern hemisphere.
Well, now, will we still be going west to east if we go down there?
Yes.
Yeah.
There's summertime. You'd be going slower.
Okay.
I did a few calculations. It looks like you could potentially go down to Borneo and end up in Australia.
So I want to show you something here. If I go to Ventusky here, and if I go over to China.
Yeah, you're not sharing right now. It's still screen.
Oh yeah, let me stop sharing.
Yeah, I'm sharing right now. Yeah. So if we go over here to Ventusky, and I'm looking at see, what am I looking at here? Let me go up to altitude here as high as I can go. I'm going to go up to 36,000 feet. So, all right, now I'm at 36,000 feet. If it'll load, and why is it not loading? Let me hit refresh, see if that'll help. Maybe it's just cold up here. Oh, you know what? I'm looking at temperature. That's what's going on. I want to I want to get off temperature and go wind speed. Here we go. This is what I wanted right here. Okay. So here we go. We're at 36, about 38,000 here. And we're somewhere, I don't even remember exactly where we were, Bill. We're somewhere.
You're on the southern edge of that
right in here now.
Project.
That's showing the winds at 118 miles an hour, but they're all going east. You know, so I don't know where we're getting this curve at, you know? The circle right here.
And right there, you can see there's a downward tilt, and if you are on the southern edge of that, you could get thrown out of the jet stream into the slow vortex, just like you did over Burma yesterday.
So if we can, I don't know, man. I'd like to avoid that, but if we can stay up here and ride that 130 miles an hour all the way over to the United States.
Be back to the U.S. in about a day and a half.
Yeah, that would be better. And if you look at this same thing on Windy, let's go to Windy, and boy, there's some good speed showing
There's
up
some
here
good
on Windy.
winds out there. It's starting to get good.
I can't even tell what
this time of year.
I can't even tell where we are. I say there's the United States. Now look at the speeds across. There's India right there. Look at the speeds across 155 miles an hour straight across. I don't know how we got off in that little bitty pocket down there.
You went a little too far south.
Yep, and then, of course, we're going to come across right in here somewhere. We're going to hit some slow, if we can. This is probably that loop. Well, I don't know. You can see the wind speeds here is 65. Wind speeds here is back up to 128, and I don't know. Well, you just can't play with Mother Nature.
South where the Philippines are, you'll see there's hardly any wind at all. So if you get caught in that loop down to the Philippines, you're going to be circling there for about a week.
Oh boy, yep. All right.
Well, I have some good ham friends in the Philippines, and I'm going to see if I can get them to start listening on Whisper.
All right. Well, hey, I listened on several remote SDR receivers yesterday or the day before, somewhere around China, Burma, in that area. I didn't hear anything.
Kuwait City had good reception on it 2 days ago. That seems to be one of the most sensitive ones in the area. Yeah. But a lot of them are not very sensitive on those remote SDR radios. You have to look at the signal to noise ratio when you click on their little icon.
Yeah. All right. So
that's the prediction. It looks like you could be hanging out over the region for a while before you pick up that circle back and pick up that jet stream. And like I say, there is a slight chance you could end up in the southern hemisphere. It's pretty rare, but it is possible. Andy VK3YT was able to send a balloon from Australia all the way up to Cuba. He crossed all the way to Cuba, and then it went back down to the southern hemisphere again.
Well, right there is the equator, right there where the mouse is, and we may be getting close.
Yep. I had one flight, my sixth flight around the world. It circled above and below the equator like a sine wave. I go about 5 degrees up and 5 degrees south and 5 degrees north for just about the entire trip around the world.
Yeah.
It's also a riskier place because the storms are higher, and particularly that's getting into a tropical zone, so you run more risk of running into big storms.
Well, that's what we want to do, is avoid the storms, of course. Yep.
But you got good signals. You were getting received and by several in southern China, near Hong Kong and Japan. And I saw one report in Alaska, too. That's pretty good range.
Must have been that 3-element beam I hung on there, that 3-element wire beam.
Yeah.
All right. Well, hey, tell us this real quick. There's been a lot of interest in Pico ballooning, and you've been contacted a lot, and you've done some stuff down in Australia here recently.
Yeah, there's 2 schools in Melbourne, Australia, that are been launching balloons, and they've been using that to teach their middle school students about the atmosphere and space and science. And I had a great Zoom call with a middle school class in Melbourne, and the other day, like I say, and it was really fascinating. Their balloon worked great. They unfortunately, it's on APRS, so there's not a lot of coverage over the ocean. So we hope it will show up eventually over Argentina or South Africa, or make it back to Argentina. I mean, back to Australia here in about another few days. But they've got there's more on the way down there, so it takes a while to ship something to Australia, but they're going to be launching a few over the next few months.
All right. All right. Oh, well, let's move on with Glenn, I guess. Anybody got any questions or comments?
There was somebody in the chat room wanting Bill's email address.
Okay, Bill, they want your email address.
WB8ELK@gmail.
All right, very good. Look him up on QRZ, WB8ELK, if you can't remember it. There you go.
And you can, I can post that in the chat room, but I'm not in the chat room right
It's
now.
Alan did it. And also, you can look get Alan's email if you buy QRZ, if you go to W2AEW, and you'll be able to get his email too. There it is. He just posted it. All right. Well, so, Dwayne is asking me to send him an email so I can tell him how to make this thing work. I don't understand why he can't get chat and the video at the same time. I think he's the only one that has told me that. So, Dwayne, I don't know if you're looking at chat or video right now. Open up a second browser. Open up a browser like Chris said. Open up one browser for video, and just make that browser half the page, and then open another browser for the chat room and make that a half a screen, and you should get both of them on there.
Now, I've got a neat little device here, Tom, that it's a kid's toy that when I went Christmas shopping, and it's a LED ring, and it's made for doing TikTok videos and that kind of stuff for the kids. But it's since my lighting situation is always bad, it's on a little tripod, and it didn't cost very much. I picked it up at a Hobby Lobby store kind of.
Well, that's cool. We need to get you a few more of those and just kind of put them all around you there.
I'm going to get more and just line them up here. My neighbor will be blinded whenever I show up on the show here.
Okay, hey, we got a person in the chat room, Okinawa. He says hello from Okinawa. This is 7J1ADJ/RJ6. So, all right, Okinawa, stick around. If it goes down, we're going to want to send you out as a search party to collect it for us.
Hey, tell him to get on Whisper, because he's in good RF range of it right now. He should be able to hear your balloon.
And the Okinawa person, as Bill said, if you've got WSJT-X, it has the Whisper program. You can put that on your computer there and your radio, and you can pick up W5KUB-20 because you're in range right now.
Where are you transmitting? Where are you on the 20 meter band on Whisper?
Yeah, 20 meter. Mm-hmm.
Was that like 14.0.070?
140956.
0956. Okay.
And right now there's some station in Russia running FT8 on there making or teletype in a DXpedition on 140956. Have you heard that, Bill?
Yeah, I noticed that.
Yeah.
Tearing up the band.
I thought it was teletype, but And they may be running teletype here. I don't know. RTTY.
I think it was a teletype signal.
Someone said it was FT8, so I don't know.
Oh, really? I'll have to look at it, listen to it again. Earlier I was listening, and it sounded like a big, strong teletype signal.
Yeah. It was. I think it was RTTY. Yeah. All right. Very good.
Well, if it gets out of the doldrums there over the Philippines, then you hit that jet stream and you'll be back in the U.S. in no time, because once you hit those strong winds, you'll be sailing across the Pacific and, like I say, going over 150 miles an hour. You know,
I was thinking, we've been in the air now about 10 days, I think. We launched last Saturday, maybe 10 days. Our other balloons, I think it averaged around 17 days to get around. Although this past month, I've seen some people getting around the Earth in, 8 days? 9 days, maybe?
Let's see, WB0 URW launched 17 days ago. And there have been some that made it around in 11 to 12 days.
Yeah, okay.
Because now we're getting into the good winds, the wintertime, late fall, early winter wind patterns, and you can, if you hit it right, you can really sail across quickly.
So let me ask you about one more. KO6FE, I couldn't find him today. Is it still reporting?
I didn't see any reports from him today. I'll have to take a look. He looked like he was stuck over in a circle in the Pacific Ocean, however.
Yeah, he hadn't been moving.
S, however, Alpha Bravo 5 Sierra Sarah -14. I've been running the Python program for him to track his, and and the Python program takes the WhisperNet data, converts it to APRS, and sends it to APRS. It's a program I wrote in Python, and so I have it running for his balloon since he's a friend of mine, and his is going around the world, and I believe, I think his was 17 days.
Yeah. Well, we're at about 13, so I don't think we're going to make 17 on this one.
Two the Mylar balloons stacked on top of each other.
Oh, he does. That's cool.
Yeah, and he made it completely around the world. That's kind of hard to do on those small party balloons.
Yeah. I think soon we'll try an experiment. We're gonna tape together 3 or 4 of those big round clear ones and 5 or 6 of those Mylars all together, man. Maybe throw a net over them, launch them all together. Oh well. Hey, Okinawa says 7Q7RU is using FT8, and he has a pileup. So maybe they don't know that's a whisper frequency. Or that might be a good place to operate RTTY, because most all the other signals are going to be weak there, right?
Yeah.
Yeah, that may be logical thinking there.
Well, they may not even be hearing the whisper signal.
Well, probably not. Yeah. Okay.
Got a question in the chat room there. Somebody's wanting to know whose balloon is WB8 ORW-8.
WB0 URW-8. He just arrived. That was launched from Pella, Iowa, where we had the Great Plains Super Launch 2 years ago. And they have an active balloon program. They're flying one of my SkyTracker APRS boards on a SBS-13 balloon, the same balloon that you're flying, Tom. And he showed up right at the Golden Gate Bridge today. So after crossing the Pacific, it was kind of neat. All of a sudden, I was looking at the West Coast, and he popped right up, right over San Francisco.
Well, you got to watch that bridge.
Away from completing his first lap around the world.
You know, Bill, it seems like to me the first one you launched for us, it seemed like it flew around 29 or 30,000. You know, it was a Mylar balloon, but I think it went over Everest. I think it went over Mount Everest.
Yeah.
And that's getting pretty close, man. What's the altitude in Everest is like what 28,200 or something? Yeah.
28 feet. And I had they had this device called an InReach by Delorme. It was a GPS tracker that had an Iridium modem in it, so you could send your position from anywhere in the world. And I was modifying it to use on balloons, but when I flew it when I tried to fly it on a balloon, it would stop reporting at 29,028 feet. That was the max altitude I could get out of it. So I'd asked the engineers at Delorme why this was happening. And he says, well, we didn't think anybody would be hiking higher than Mount Everest.
Right.
Well, it is a little hard to do that.
Well, hey.
They had designed it for people in remote areas and hiking. You know, they never thought about using it for high altitude balloons.
Okay. 15-second story. It's not ham related, but since we're talking about Everest. So last night I was watching King of Queens, and he had this book about climbing Mount Everest. And his wife and he went to some big party with his wife's boss, who was a climber. And the boss asked Doug, says, do you climb? He says, yeah. He said, how high? He says, 29,200 feet. He says, what? He says, that's Everest. And he says, yeah. Well, and then later in the conversation, you know how the mountain climbers sometimes with frostbite, they lose a toe or whatever, have to have it amputated. Anyway, he was telling the boss that he lost a toe going up there. And the boss said, well, when did you lose the toe? And I don't know. He says, I just took my shoe off and it was gone. Oh, yeah. Oh, well, maybe the audience maybe caught that, but it's kind of like, it wasn't amputated. It just, the toe was gone when he took the shoe off, man. All right, let's get over to Glen.
29,200 feet.
Yeah, what? What, Glenn?
Yeah, at 150 feet above Everest, I'd be losing a lot more than a toe.
Right.
Yeah. All right. Hey, Glenn, what do you got going tonight, man?
What I got going?
Yeah.
Oh, well, I'm still working on the book just as hard as I can. By my estimate, I'm down to about 7 to 10 days to finishing. And let's see if I can't find the screen that I've got popped up here. Because I've got a screen. There we go. There it is. And let's try this. There we go. Wait for my computer to get its act together.
You need a bigger UPS supply. We're not getting that screen.
Yeah, it's working at it. Has to. I'm using Windows 7. It has to convert video and stuff for Zoom to make it format compatible. And there we go.
Well, it hadn't got here yet from Mississippi.
There it is.
There it is. Well, there it is. It made it. Oh,
there it is.
Oh, hey, there's nothing in there.
No, there's nothing in there, huh?
Yeah.
That is actually a MOSFET driver for the Peltier controller. I've got a project here.
Yeah.
Show you this. This is the actual controller for it. Uses an infrared temperature sensor, like the ones they use in the handheld things. They take your temperature at the store. Yeah. And this is basically designed to be a touch-free or a fan-free, no-contact temperature sensor that will drive a Peltier cooler. And there's the module. It's attached to a CPU heatsink. And it's got a fan on it, and that was just for testing. But you're talking about 150-degree temperature differential between the cold side and the hot side.
How much does that thing weigh? Let's put it on a balloon.
Well, the cooler itself, it probably weighs about the weight of a dollar coin, maybe.
Yeah. Now, doesn't that thing make heat on one side and cold on the other side?
Yes, and it's 150
How cold
something
can you
degrees
get it?
difference.
How cold can you get it from room temperature?
Minus 158 degrees from room temperature.
That's what you need to test your LiPo batteries out there, Tom.
As long as you got a big enough heat sink to keep one side at room temperature when you start doing that.
Yeah.
Well, that's why I put the fan on it, just to see how cold I could really make it.
Yeah.
Well,
And, like I say, we've got an IR sensor that's actually sensing right at that heat junction there.
well, see, we don't
How
need
much power to take
we-
to drive that to get the full 150 degree temperature?
6 amps at 12 volts, 72 watts.
That's going to take a lot of solar cells.
Yeah, you're gonna need more solar cells.
Hey, we used to use those little Peltier coolers going back, let's see how many years ago. My first job out of college, I worked for a company that we did fiber optic data links. And one side of the house, we used Fabry-Perot laser diodes. And we actually used the Peltier coolers on the optical bench of the laser diodes to tune the leasing frequency of the diodes.
The thing is, they've gotten so cheap now. I mean, that's like 1.5 inches by 1.5 inches square. And I found a bundle of them on clearance for $1 each.
Yeah, the ones we used were teeny tiny because they were probably 1/10 of an inch or 2/10 of an inch on a side. They're really small because they would go inside of a bathtub, like 16-pin dip style package with the laser mount on top of that, and then a thermistor in there to kind of hold temperature, and it was kind of set into a circuit with a feedback loop to kind of maintain the laser at a given temperature for WDM applications.
So
Yeah.
So Glenn, what are you going to use this for? What do we do with
Well,
it?
it was just one of those fanless cooler ideas. Let's say I had a rig that I wanted to cool without using a fan. I wanted it silent.
Yeah.
I could do something like this. And my original thought was, with all the COVID stuff, it'd be cool to build my own hands-free thermometer. And as it turns out, the hobby module versions of that infrared detector are only accurate to within about a half of a centigrade. So that's like 2 degrees. They do make a medical version that's far more accurate, but I didn't get that. I just got the standard one. And that's when I came across this idea. And of course, you've got to monitor it. And the temperature sensor actually can sense temperature and ambient temperature simultaneously. So you've got your room temperature and then the temperature of the object you're getting the temperature from.
Mm-hmm.
And then I'm driving it with PWM, because literally with these Peltier coolers, if you put your fingers on both sides of it, the heat it pulls from your finger will actually cook the finger on the other side. It gets that hot that fast. So that's one of the book projects that we've got going. This is another one of the book projects we've got going. We do a lot of playing with, my room's being destroyed.
I hear that.
But this is actually a rotor position indicator. We tap off of the rotor potentiometer coming down, and that's actually a circular LED behind that little silver mask. And it will actually point in the direction, because you look at this meter and like it says it's east. Okay, really? I have to do the translation in my head, which direction is east. This way, the little LED will point. And we also followed that up with this other one here. Do you remember those old 60s commercials for the Mercury Cougar with that blinking tail, the flashing tail? The sequential LEDs. Well, that's what this is. While your rotator's turning, it will sequentially blink the LEDs in the direction that your antenna is rotating.
And it would be a neat addition to that project, Glenn.
Well, there's actually both of those are in the same book.
I was going to say, a neat addition to that project is if in the code you could build in the beam width of your Yagi. And
Oh,
then
yeah.
direction could indicate by intensity where your main lobe is and where it's fading out on either side to kind of get an idea on your compass heading of how far off the side you are.
Yeah, you could. Now, this ring is only a 12 LED ring, so that's going to cover 30 degrees per pixel.
Yeah.
But they make much larger ones. They've got a 4.5-inch diameter ring that has 60 LEDs.
Okay.
And you could actually, you could easily do beam width within that one.
Yeah. And then even like intensity gradient. So as you get to the edge of the beam width, have the LED be a little bit dimmer, kind of be an intensity.
Well, these are RGB LEDs, so you can do anything.
Yeah. Cool.
You know, they're PWM, so you can dim them and brighten them. So you could literally do exactly what you're talking about. The edges could be dim, and
Yeah.
the center could be bright.
Yeah. Very cool.
And those are only like $5 for those LED rings. They're very cheap. And then this is the mod itself to get the fact that the antenna is rotating. We actually read the switches here, and we bring them to optocouplers because you're bringing in about 30-something volts in there. And so we use optocouplers to isolate those signals and then feed it over to the Arduino at 5 volts. And it's just
that's
a
cool,
real
man. That's cool.
simple mod.
So you could just about put that on any rotor that has a potentiometer in it, couldn't you?
Yes. The book, we're doing it for the Yaesu, G450, 800, 1000, and the CDE high gain. Because 90% of the CDE high gains, they all have virtually the same circuit. They haven't modified that circuit since 1950.
Mm-hmm.
Yeah, the only thing they added was a brake. And everything, I mean, the diagram is the same one they did from the 50s. And
You
then we're
must
back
have a
to-
large supply of perf board.
Oh gosh, that's the number one thing I buy. You know, the perf board there, and let's see. Then I buy the Arduino proto boards, and that actually is a shield that stacks on top of an Uno.
Mhm.
And the enclosure is built for an Arduino Mega, so it's got that extra space, and I use that extra space to put my switches and connectors and stuff, and it fits an Uno just perfectly in there.
Glenn, one of our followers, viewers here contacted me. He writes Whisper software, and he's designed this little Whisper transmitter, Arduino based. And I think I'm going to build that. I'm going to get with him here soon. We'll probably do something like that on the show here and build that. I still want to build that Whisper receiver that was in that magazine we talked about earlier.
Yeah.
But I was having trouble sourcing some of the parts there. Well, you got any other projects there you want to show us? Or was that the two you're going to feature tonight?
That's what I'm going to feature tonight. I think it just hit the floor. The janitor came in and decided it was time to clean my desktop.
Well,
this is the next project,
oh man,
and we even have pictures in here. Don't have those up on the screen yet, but what we are going to do with this one, find one of the pictures here. We are going to take the AR40, the high gain AR40 rotator controller. We're going to build one from scratch and interface it with Ham Radio Deluxe. And then we're going to take an existing one and modify it. And that's what's in this next chapter.
that'd be cool. Yeah.
And I'll be able to show that next week.
Well, all right. Well, look, hey, Dwayne in the chat room says he wish he had internet, satellite internet. I guess he's got some kind of internet problem. So you guys may remember Exceed. I forget who this is, but this is the guy from Exceed. And if you guys remember, for about 3 years at Dayton, Exceed put in the satellite internet for us, and we had our own satellite link there at Dayton to webcast with, and it was pretty good service. And if you're interested you can contact Exceed. He said there were no carriers that he could get, but EXEDE, Exceed, and they can get you some internet out there probably. All right. Well, all right, guys, we're finishing just a few minutes early tonight. What else is going on? Anybody else got anything interesting they're working on here?
Well, I'm hoping to have time to build a RTTY reader that you'll actually just feed audio from your rig and have it display RTTY on one of those little 2-inch color TFT displays. I saw
a video today. It reminds me, I saw a video today on YouTube. 1960 technology. It was on the BBC, and they invented this CW to a typewriter interface, and they had this guy there sitting, and he'd go, da da did it, da did it, and it would, the typewriter would go A, B, C, and this guy, he could spit the code out with his mouth real fast, and he said, well, this is a new invention, and it's like, what about people that are blind? I mean, you can type now, but all they have to do is learn the Morse code and go, da-di da-di, da-da-da, or whatever, I'm thinking, gee, there ought to be a simpler way in 1969 to do that.
Yeah,
but, it was funny, and then he sent a command. He sent a command by did it da did it, and then he says, now I'm going to dial this telephone with it, and he sent a command and he made a phone call with it by sending Morse code. Oh man, it didn't look very efficient to me, but they
were just experimenting with new technologies back then. I mean, think about this. In that era you're talking about, they didn't have automatic doors at the grocery store. That was a Star Trek thing. And even when we saw it on Star Trek, we were like, there's no way you can do a door that we're not going to walk into. It's not going to be smart enough to know that we're standing in the middle of the door. Well, now look at what you got. I mean, you don't even think twice when you walk into the grocery store.
There have been a lot of developments since then. I mean, I was overseas in Asia in 1971, 72. No internet. I mean, I had to write a letter back home to my wife, and to make a phone call, I had to go to the telephone building and get in line, and the operator would actually make a call to the States, and it might take 30 minutes to get that connection. But boy, I mean, today, it would have been so nice to have email back then, It's, wow, things have changed.
Oh, yeah, I mean, back then, HF and phone patches for the guys overseas was the big thing.
Yeah.
You could tune in on 20 meters almost any time, and somebody was running a phone patch for somebody.
Yeah.
And who runs phone patches anymore?
Yeah, my phone patches are on the top shelf in the closet now. Yeah.
But no, the technology is just getting faster and better every day. And the things we thought were impossible are now commonplace. For example, I was just watching a little video earlier. What is that new show they've got on? It's one of the streaming services, The Mandalorian. Is that Disney?
Well, I don't know.
The Star Wars TV series. They're using an Arduino now to power their stop motion physical shots, their special effects shots are being powered by an Arduino and a 3D camera head.
All right, before we go tonight, let me ask the people in the chat room, guys. We've done some audio work here the last couple of weeks. We added a Behringer Compressor Pro limiter compressor, and have set it up, and it's supposed to try to level out the audio. Has the audio been fairly level tonight? I noticed with the compressor on, the audio sounds a little different to me, but it seems like it's keeping the loud spikes and stuff down. I can probably turn it off here a second. I'm going to turn the compressor off, and let's see what it sounds like. All right, the compressor So I don't know if it's going to make a lot of difference or not. Give me in the chat.
Yeah, they're saying you're way too hot.
Yeah, it's real hot. So I'm going to turn the compressor back on.
You said something about the stereo left and right being out of phase.
Yeah, I got the compressor back on now, so it's limiting it. Now, what did it say about right and left? What was that?
Left and right, your stereo is out of phase.
Out of phase. Okay, I need to fix that.
Yeah, I noticed, I think I tuned into the recording that we did last week, and I noticed as soon as the audio came on, something sounded weird in my ears, and maybe that's what it was.
Okay. Any ideas of how to fix the phasing of that?
Not a clue.
Something about, Mark says the commercials are correct. Well, Mark, the commercials are a video file I run on the computer where they're not audio coming in through the compressor, so there's something to do with the tip and ring and sleeve on these and another thing too, the a lot of the jacks here that we plug in are stereo to mono converting jacks. So
well, Ron is saying that they're hearing a guest on the left side only, so we may have a stereo to mono missing somewhere.
Well, I'm seeing, Glenn, when you talk, I see you on both channels.
Yeah, but it makes sense just to make it mono, just to tie everything together.
Yeah.
Well, you may see me on both channels, but something may be shifting me out of phase somewhere further down the line.
Yeah, I got to figure out.
When I do my videos for anything for YouTube, there's no reason for me to leave things on stereo, so I typically do my rendering mono just so that I don't have to worry about if I was too far to one side of my camera or stereo microphone or the other. I just let it render in mono.
Yeah, I'm gonna have to look into this. I'm not sure what to do or where to do it, to tell you the truth. But
I'm a digital guy. I can't help you there.
Yeah, I need an audio engineer. That's what I need.
Not me. I don't have ears for it. My ears got blown out all the concerts I went to in the 70s.
Yeah.
Funny, Glenn, you said you're a digital guy, but I got a question the other day. Guy watched my video, my tutorial on IQ signals, and he said, "Hey, that was really good. I really learned how to do something. Do you know how to do that in Verilog?" And I told him, I said, "I'm an analog guy. The only thing I know about Verilog is how to spell it."
I don't even know how to do that. Analog is probably my weakest point. I came up from the tube era and transitioned into transistors and did a little bit of analog there. But once I got my hands on digital, it was Katie bar the door. That was what I was good at.
Well, I was hoping Martin would be here tonight.
That
we would talk about analog probably for sure. And I mean, Martin's a sharp guy. I'm sure he knows all about digital. But back when we started, and you guys too, that's all it was out there, just analog stuff.
Yeah, no, he is an absolute.
That's all I've ever done is analog design, analog integrated circuit design, discrete design. It's all been analog for me.
Yeah, for me, transistors were meant to be switches and nothing else.
Well, I worry about everything in between those two extremes.
Yeah.
Yeah.
They're getting there.
Well, see, if I need one of those, I go and get an op amp. Those I can figure out.
Well, that's just a pile of transistors anyway.
Yeah, but it's simpler. Yeah.
All right, guys. Hey, let me just make an announcement again, guys. We're on WBCQ. International Shortwave Station, WBCQ. We've just moved to 7490 kilohertz. Back in my day, that was kilocycles. I can remember it now. I had to think about it.
Yeah, I don't know when they changed that, but I liked it back in kilocycles, man.
Yeah, what's the difference? Anyway, so we're going to be on Thursdays. This show will be on Thursdays between 5 and 7 p.m. Eastern Time on 7490 kilohertz on WBCQ shortwave station. So if you're listening out there on shortwave, send us an email. We'd love to hear from you. Send that email to Tom at w5kub.com, Tom at w5kub.com, and let us know where you're at and give us a signal report. We'd love to hear from you. And if you're interested in ham radio, that's what the show has been all about tonight. Many different aspects of ham radio. You can join the show on Tuesday nights if you have internet by going to w5kub.com, and you can watch the show and join in a chat room. And also, we'd like to invite everybody out there to join our Facebook group. We have a Facebook group for this show, Amateur Radio Roundtable, and that Facebook group now has over 11,000. That is 11,000 hams. I didn't think we'd get there, but it's growing every day. Join us. Just put in W5KUB. It'll take you to it, or you can actually key the name of the show in. The show is called Amateur Radio Roundtable, and it'll also take you there. And we'd love to have you. Post your pictures in there. A lot of people will post shack pictures. Katie will probably pull your shack pictures off, and we'll have a review of all your shack pictures on a show one night. But, there's all, if you're interested in ham radio, it's not just talking on a radio. As you saw tonight, there's a lot of different things like what Glen Popiel's doing and our balloon launches that Bill's involved in. And there's so much of to do in ham radio. I don't think you could do it all in a lifetime there. It's 9:32 p.m. Central Time, so I think we're going to go ahead and close the show here in just a minute. I got a package in the mail today. It was a water pump that goes on a dishwasher. So I know what I'll be doing in a few minutes. I'm gonna be underneath the dishwasher changing a pump out.
I've got a dryer that had a heating coil go bad. They replaced that. Now the drum won't rotate, so I think they had a wire fall off or something. But I pay people to do that.
Oh yeah.
I'm
Things are so things get complicated nowadays. I mean, hey, when I grew up, I could work on a '57 Chevy. I could crawl under the dash. I could trace the 3 or 4 wires that were under there. But try it today, man. It's impossible.
Well, there's this meme going around on Facebook about, when you bought a car in the 50s, the owner's manual included how to set the valve spacing.
And
now they include these warnings,
everything.
don't drink the gasoline.
It set the points and set the valve tappet clearances and everything. Yep.
Yeah.
I bet you can't even find the points on a car today.
Well, no. First of all, it's all electronic.
Yeah.
Now the actual coil is on top of each spark plug rather than a separate distributor coil.
Yep. Yeah, my poor dwell tack meters are sitting collecting dust in the cabinet in the garage.
Okay. Hey, Ron, K9. Hey, real quick, breakthrough here. K9ID Ron, our buddy Ron up here. He looked at the right and left channels here. He opened up an audio editor, and he says definitely they're out of phase. So Ron, help us, man. I got to figure out how to get them back in phase. That should mean just taking one side somewhere and flipping it over, I would think, but I'm not sure.
Probably in your main mixer.
I'm not sure, man.
Are they out of phase by 180 degrees, or is it something less than that? So if they're 180, then it's an inversion issue and it's easy. But if they're out of phase by something not 180, then that gets trickier.
Yeah. I don't know, man. I ought to be able to just take 2 wires and flip them over.
Yeah.
I mean, hey, that's what Bob Heil does on his headset. He's got a headset out there.
It's got a little switch on the side of the headphone.
Yeah, this is a Heil Pro Set 3 right here, and there's a little switch. There's a little switch on this side right here, a little toggle switch for phasing, and all it does it just turns one earphone over opposite of the other one. It just switches it. So I've got to add this switch into our show.
Looks like Ron said he's going to send you an email with a screenshot. So from that, you should be able to determine if it's 180 degrees out. Then it's got to flip one.
Yeah, well, send it to Alan too. Alan is the one that's got all the high tech stuff there. He can I mean, he can tell us what to do, but I definitely I don't like the sound of the audio. Actually, it to me it sounds a little funny, and I'd like to try to fix that. All right, I'm gonna turn the compressor off.
And you run your lapel mic?
And I'm going to try to crank the volume down so I don't clip here. So, all right, now guys, comment to me. I'm sure the audio probably sounds better out there in the chat room. So the compressor is off now. And I backed
nobody complained about the phasing until you went to the compressor. So it may be, yeah, now they're in the chat room, they're saying the phase problem is gone. So it's something with your compressor connections.
The phase problem is gone now? Yeah, I would imagine so, because before I put the compressor in, it sounded normal to me. Now, the compressor has a relay in there. This compressor is actually designed where if you turn the power off, it bypasses it. So that's what I did. I turned the power off and it bypassed the compressor. So it's got to be something, man, I don't know. We'll
now, Russ is saying the grounds of both have to be connected. I think that would be a given.
Yeah.
But it's definitely something to do with your compressor doing it or the wiring of the compressor.
Tom, did you try your lapel mic? Is that wired in through that compressor?
Yeah, everything goes through the mixer, and then it goes through the compressor. So it's gonna sound.
Everybody was out of phase. So
it's gonna sound the same. Let's see. I'm on the Heil mic now. Heil mic 1, 2, 3, 4. And there's the lapel mic 1, 2, 3, 4 lapel mic, and there's the Heil mic 1, 2, 3, 4 PR40 1, 2, 3, 4, and the lapel mic 1, 2, 3, 4. Should be able to tell a little difference. I don't need this now. All right, let's see what they're saying. Hey, maybe we'll have someone here that tells us exactly what to do.
Andy said try changing the compressor oil.
Yeah, that's what I was gonna say.
I may have to change the compressor oil. Well, you know what? This is one of those oilless compressors. Yeah, this is an oilless compressor.
Yeah, what are those? What do they call those? The scroll compressors?
I don't know.
They call them loud.
Yeah, and mine is pretty loud out in my shop. Let's see. Okay. The grounds of both must be connected together. Well, I'll have to look at that, and we'll see.
Well, also you've got multiple channels. Well, I guess it's if everybody's got the inversion, then it's got to be something that the tail end after you've mixed everybody together. So, interesting. Oh, there's multiple channels on that thing. Maybe you could switch channels, and see if the inversion stays with that. But it's something that if you got a 2-channel scope there, it'd be pretty easy to put a test tone in on left and right at the input, and then look at the phase at the output, and just work your way through it that way.
Yeah. So if they're out of phase, I guess they're canceling each other. How can anybody even hear us out there?
Well, because they have to go through your brain matter, and your brain matter kind of takes away the perfect 180.
Yeah, well, that's something I'm gonna look into this week. Maybe by showtime next week, we do something. I don't know what it is.
All right.
I don't know. Okay, guys, I'm gonna.
Tom, I was gonna say real quick. You got to remind me. The very first show that I was on, is that when I did did I do the Nano VNA talk then?
I think so.
Yes.
Yeah.
Okay.
Yes.
All right. Yeah, I'm actually giving that one again tomorrow night to a group of about 300 on Zoom.
Yeah. Okay. Okay. All right, everybody. Thanks, everybody. We'll say good night to everybody. Glad you joined us tonight. We're going to end, let's see, I'm going to end this thing with something. I don't know. I always look for I don't have any good thing to end it with tonight.
have to get you some new good stuff.
Yeah. Let's just end it with the Glen Popiel lookalike again. Here we go.
I am going to put
So you're
some
saying I
aluminum-
can ask
Here we
this
go.
cat any question?
The cat is connected to the computer. You just type in the question.
Doesn't he look like Glenn?
Read his mind.
That looks like the cat if you took away the white.
There's the answer
Oh,
code.
my Glenn.
You're the man! I've been looking for this for weeks.
All right, guys. Good night, everybody. We're gonna end the show. See you later.